Hi everyone, we prepared a short MATLAB Simulink tutorial for EE361 course. But first of all, let us introduce ourselves. I'm Hande Bayezid. I'm one of the coordinator assistants of this course, and I also have my friend Gökhan Çakal here. He is the other coordinator assistant of this course. In fact, we have prepared another MATLAB tutorial. Our friend Furkan Tokyos prepared that one for EE463 course. But we believe that in that video, they have dealt with some more advanced problems. We are planning to show you a brief, real introduction to MATLAB and Simulink. Also, in Furkan's tutorial, Furkan used MATLAB desktop version. Now we will use MATLAB online version as you all have access to that version and to all other toolboxes. So we're recording this video using Zoom. Now I will share my screen. So at first, what you have to do is go to the website, mathworks.com. Here you can see there's a link to the login page. I already created an account, but first you have to create your account using your Metu email address. Metu bought us all licenses, as I said before. So that's why you have to use your Metu email address. So let's log in. This page welcomes you. Here on the left pane, there are several links. What we will use is MATLAB Drive and MATLAB Online. MATLAB Online is the software itself. MATLAB Drive is the cloud storage of Mathworks. Having simulated your models, having created your Simulink models or M files, when you save, these are all saved in the cloud storage. You can download them to your local database, or maybe if you would like to work on a specific data set that is currently on your computer, you can upload it to the MATLAB Drive and work on them using MATLAB Online. So let me go back. Let's see the software. I suppose most of you are familiar with this one, as last year in EE213 course, you have used MATLAB to plot your figures. Having taken your scope data using the related Agilent software, I guess, you plotted your figures by writing some scripts. So what you have to do first is opening a new script, of course. You can define your variables, you can type your equations or necessary scripts to generate a figure or whatever you like. After that, in the editor tab here, when you click run, it's all set and you pass your variables to the workspace, your scripts are run and you obtain whatever you like. But here I would like to show Simulink mostly, as I think you also know just a little bit of these. In the Home tab, here is the Simulink button. When I click, it directly opens. Actually, it's faster than the desktop version. So there are several templates. We will use blank model. Let's create a new model. Simulink is a software is an environment that converts your models, your realizations, or whatever you are dealing with to mathematical equations. And to be able to solve these, there will be some requirements. You have to specify some parameters. These are, for example, the solver type, the step size of the simulation, and the stop time of the simulation. Solver type, I suppose you will not be dealing with the solver types. It's a bit kind of advanced. But what you can see is what you have to specify is step size of the simulation. You have two options. One of them is choosing a variable step or a fixed step. Variable step is faster, solves faster, but sometimes it's not that accurate. If your result, if your outcome has very small derivative, the step size grows, and sometimes this gives you unreliable results. I usually choose fixed step size. It's slower, but it's better, I think. And another thing, the stop time of the simulation. It's actually the total duration of your simulation. Nothing much to specify, nothing much to say. Now let's have a look at our library browser. Library browser includes all the necessary blocks and toolboxes that you can use in Simulink. If you know what you're looking for, you can directly type on your space on the whiteboard here of the name of the block, and when you slide it, when you press enter, it's placed, it's located in the model. If you don't know which block you're looking for, you can check these categories. You can search here. As you see, there are several categories. I'm sure that you will not be dealing with most of them. Now I will introduce only the basic blocks under Simulink category. Here you see there are some math operations, signals, basic display blocks. Actually, I built a simple basic Simulink model. Having introduced these to you, I will directly go from that model. Here we have some continuous transfer functions, derivatives, integrals, state space blocks, delays. We have sources. Sources generally include the signals or constants, or maybe clock, which actually shows the simulation time. And from workspace block, which is important actually because it allows you to get some variable, get some array dataset from the MATLAB workspace. And we have sinks block here. Display and scope will be, I think, most used block for you, most used blocks for you, and workspace block, within which for which I will be talking about in just a minute. Now let's check the model I built for you. Tutorial SLX. What I done is very simple. I formed two sine waves using two different approaches. As I said before, this is a clock block. Clock denotes the simulation time. I multiply this with a gain block with omega, a frequency, some frequency, and I pass this to a sine wave function, a mathematical function, and amplify it with some amplitude. And here I also obtain a sinusoidal using directly the sine wave generator block, and multiply these and show both sine waves and the multiplication using an oscilloscope, a scope. And also I take the output variable to my workspace. Now let's run the simulation. What I want to see, what I expect to see is two identical sine waves and another sine wave with twice the frequency of them with a DC bias. Let's see. Exactly. If I want to specify which line denotes which sine wave, I can also activate the legend over here. I can also name the signal roots. As you see, yellow line, which is under the blue one, denotes the first sine wave. The blue line denotes second sine wave. And the third one, the orange one, is the multiplication multiplication of them, and the result is as expected. Now let's have a look at under these blocks. As you can see, there are several parameters of this sine wave function, like amplitude, frequency, or phase. You can either type the numerical values of them, or you can assign a variable to these. When you change the numerical value of the variable, here the value of the parameter also gets updated. For more complex models, this will be easier for you. For example, let's say you have 5 sine waves in the same block and you would like to observe the change of the amplitude of these 5 sine waves. You can either type and double-click, type the amplitude, new amplitude, and do this 5 times. Or you can assign a variable and change the value of the variable easily from the workspace, and you can observe the changes between the two results. Also, another thing I would like to mention is this to workspace block. This block allows you to take the simulation results to the workspace, obviously its name. If you would like to manipulate your simulation data, or if you'd like to save this as a CSV file to use for different purposes, I don't know, you can use this block. You can specify the save format as time series array, I don't know. When you run the simulation, let's check the workspace. Here there is an output, simulation output variable. You can see there is output time of the simulation and this sine wave array. You can see the values of the sine wave for the simulation. If you'd like to plot your output data set using a script, you can use this block. I think that will be all I would like to say about basics of Simulink. Thanks.
Okay, I will continue from this step. Hello everyone, I'm Gökhan. I guess we have met with all of you. I will briefly talk about this basic steps of Simulink, and we will simulate a basic circuit, as you can see here, in which we have a three-phase voltage source, which is fed by this three-phase RL load, and we will observe the current and voltage of a phase, and we will plot them as you can see, as you will see in the scope. However, before start saying this, I want to show you the some properties of Simulink. Let me show you. In modeling tab, we have model settings, and when we click on them, you can see the solver details and solver type. In the solver type, we have variable step and fixed step size. This fixed step size and variable step size adjust the simulation step time. For example, let's say you want to have a simulation of our grid voltage, which we have 50 Hz frequency. So in order to obtain accurate results, you have to at least have 20 points in a period of a signal. So in 20 milliseconds, you have to have maximum step time of 1 millisecond. So you can say fixed step time and adjust the fixed step time to, for example, let's say 0.1 millisecond. And with this adjustment, you can accurately simulate the 50 Hz frequency. However, if you don't want to adjust these steps, you can simply select the variable step. So this step size and this adjustment determines the accuracy of your simulations. Okay, I will choose variable step time, in which the Simulink adjusts the step time automatically. Okay, let's build this model from zero and simulate the circuit. First, I will open a new Simulink model, blank model. Okay. By pressing Ctrl S, let me save this file tutorial. Okay. Okay, as Ande said, we will use Simscape Library throughout this course, which is located under Simscape Library, electrical tools and specialized power systems, and what we will use are located here. We will mainly use fundamental blocks. Under fundamental blocks, in order to use this Simscape library, you have to put this power GUI to your model. You can put a block to your model by clicking right button of the mouse and add block to model tutorial, or you can simply just sweep them. Okay, as I said, we will have three-phase voltage source. This is located here. We have also other voltage sources, which you may use in your projects or laboratory simulations. And we will have a RL load, which is located under, let me see, under elements menu. And when you go down a little bit, we have here series RLC branch. Okay, also I will also add this to my block. And lastly, we will have some measurement blocks, which is located here. We will measure current of a phase and voltage of a phase. And these are all, I guess. Okay, let me arrange them. You can control this, and you can copy this and paste for in order to get three-phase load. Okay. We will have 50 Hz frequency and phase-to-phase voltage of 400 volts as we have in our grid. And I will ignore the impedance of the source, and this is adjusted. In order to measure the phase voltage, I will have Y connection and neutral connection. When I change the configuration, as you can see, neutral connection is here and ABC connections are located here. Let me adjust our loads. I will have an RL load with resistance of 2 ohms and 5 milliohms, 5 millihenries. Okay, let me delete them and copy this one. Okay, in order to connect two blocks, you just simply connect the terminals to other terminals of the block, as you can see here, by clicking and holding your mouse button. Also, you have to connect Y connection, as you can see here. And as I said, I will measure the current and voltage of a phase. In order to achieve this, I will delete this connection and place an current measurement block here. Oops. And in order to observe a voltage, I will again use this voltage measurement block with plus and minus polarity. Plus is connected here and minus is connected here. Okay. Lastly, I will have a scope in order to observe the measurements. In order to achieve this, you can use this library, open the library and select scope. However, for a fast reach, you can simply type scope on your model. Okay, as you can see, we have only one input. However, we want to measure current and voltage. In order to obtain two inputs measurements, you can open the scope and number of input ports. You can set this to 2. As you can see, we increased the number of ports to 2, and I will first measure current and voltage. Okay, I set my blocks. Lastly, I have to adjust the simulation time. As you can see here, we have 10 seconds of simulation time. However, we have a fundamental frequency of 50 Hz with period of 20 milliseconds. I want to observe 3 periods, which makes its simulation time of 60 milliseconds. Okay, I guess I set everything. In order to run simulation, you can click on the Run button. Okay, simulation is done. And as you can see here, my results are plotted. However, I don't know which one is voltage and current. In order to understand this, you can name the signals here. For example, I will double click on this and name current. And let's take voltage. But after that, I want to show the legend. Okay, as you can see, current is yellow signal and voltage is blue signal. We have around 330 volts RMS voltage. And this is all, I guess. Thank you for your attention.